Well, thank you very much. It's a pleasure to be here in Bermuda. And I'm the executive director of Moat Marine Labs in the Florida Keys' new International Center for Coral Reef Research and Reef Restoration, a brand new type of topic. And what I'm going to do today is kind of unique. I'm going to ask you to be a part of this talk, and I'm going to ask your help. So it's not a hard job, but I want you each to follow me in a couple deep breaths. You ready? Inhale. Exhale. Inhale a little bigger this time. Inhale. Exhale. Okay, congratulations. Everybody does like to breathe, but most people don't realize that the first breath you just took, you can thank the forests and the trees and the plants that photosynthesize and produce extra oxygen. But that second breath that you just took, that larger, deeper breath, you should be thanking the oceans. And that's because the oceans are 70% of this planet and provide, through phytoplankton, seaweed, algae, and coral reefs, the oxygen we breathe. Everybody likes to breathe, right? Well, what else does coral actually do? Most people do realize that they are less than 1% of the bottom of the ocean, but yet they provide 25 to 40% of all the fisheries we like. Everybody likes to eat, right? Well, what else did they do? Well, our oceans are one of our biggest economic steamboats here, with cruise boats, with snorkeling, with diving. Places like Bermuda, Florida, and the Caribbean realize that it's one of their big mainstays. If we don't have the reefs, we don't have the tourist dollars. But one last fact I'd like to talk about that most people don't realize is that living coral reefs break the storm waves, the surges, and the hurricane damage that actually allows us to live along the coast that we love. Without those coral reefs, and without those coral reefs being alive and growing as sea level rises, we will not be able to breathe, eat, economic jobs, or live near the coast that we love. So we should pay attention to the reefs. And many have seen in the news that the reefs are in trouble. But what is really happening here? The picture on the left is what the reefs used to look like when I was growing up and snorkeling, full of staghorn, elkhorn, massive corals. And since the 1970s and 80s, when sea level temperatures started to rise, we started to lose our corals. In some locations, the same picture on the right is the same spot taken just a few years later. Well, what's causing this and what can be done? Well, we can do a few things locally. We can protect marine protected areas. We can wait, hopefully, in protection from some of the stressors locally and hope that Mother Nature comes back. We can improve water quality locally and hope that Mother Nature comes back. We can do the best thing we can, which is to lower our CO2 emissions. Because without that, the long-term corals are in deep trouble. So globally, we must lower those CO2 levels if we really want the corals and all of us to survive. But what can we do now? We can actually restore living corals. Well, what do you mean, restore living corals? You're going to put corals back just so they can die? Well, one thing that we found out is the corals that are out there today are the ones that survived the last 30 or 40 years. I want to show you a picture of an elkhorn coral. And in an elkhorn coral, when the temperature gets high and it bleaches, well, what you'll see here is the coral on the right is bleaching. The coral on the left is not bleaching. A little bit later, we find out that eventually the coral on the right that bleached dies. The coral on the left did not. So if we can take those corals, the ones that are resistant to today's conditions, and we can make more of them, we can build a new reef. But how are we going to be doing that? Most people think corals grow very slow, right? Well, we can do it with coral nurseries, and that's being done now with one of the faster growing corals, the branching corals, The staghorn corals, the ones that looks like a deer's antlers. This species actually evolved for years to be a fragile branch. When storms came and broke it into pieces, some of those pieces reestablished on the bottom and grew back to be a new coral, sort of a vegetation reproduction, just like you would cut a plant. We can do that underwater in coral nurseries, and it's one of the old tricks that is now being improved with technology for ways to grow those faster. A 1-inch piece of staghorn coral in 6 months to a year grows 10 more inches, and then we can plant some of those. Here's a quick example of 5 pieces planted on the bottom. 1 month later, they're starting to grow already. 5 months later, they're really being looked at as large growth. And 7 months, and actually almost 1 year later, has actually made a habitat for the fish, a functioning ecosystem in just 1 year. So this is great news. However, this is one species, and this is one species that has been done for a while. And it has good survival, but this is a species that usually doesn't live too long, 3, 5, maybe 10 years. What about all of the other species? The slow-growing corals, the massive corals, the ones that actually build the reef up. Well, they are slow-growing corals, and they have not evolved to break into pieces. And so this is a very tough one. Normally, something this big may only grow a tiny fraction of an inch in a year. So this one's real trouble. So what should we do? Well, let's forget about it, and let's just talk about sex instead. And we're talking about sex because actually corals have sex. They actually spawn, like you would think of a Bermuda glowworm or a fish in aggregations when they have a time of the year when they'll reproduce. And by chance, they may come together. It occurs usually in the spring of the year, just like the glowworm. It occurs at a certain time. It's usually in August. It's usually after the full moon in August. It's usually 2 days after the full moon in August. It's usually 2 days after the full moon in August and exactly 2 hours after sunset. So how they do this, we do not know. But they spawn and release billions of sperm and millions of eggs that float to the surface. We didn't even know this occurred until the 1980s. But now we know that the massive corals reproduce sexually, just like the birds and the bees and the flowers and the trees. But they're very small. Small larvae are the size of a head of a pin or smaller. And by chance, this little tiny organism, and only 1 in a million actually makes it. Wait a minute, did I say 1 in a million makes it? I meant 1 in a million makes it maybe every 25 to 100 years. How can that be? Well, some of these massive corals are living 100, 800 years old. So if they're successful once a century, they've replaced themselves once. If they live 500 years, they may make 5. But we've lost 25 to 40% of the world's corals in the last 40 years. Do we want to wait 100 years to happen again? No. So 10 years ago, we collected about 1 million of those eggs, brought them back into the laboratory, and literally produced one of our first test tube baby corals. At 1 to 3 months, that picture on the left is actually through a microscope because they couldn't even show you on a regular camera. That's a 1 to 3 month old coral, those little tentacles sticking up there. Now I know why only 1 in a million makes it. 3 to 6 months later, that picture looks beautiful on the right. That's the size of a head of a pin. So it's amazing these things make it at all. Well, what we found out with those first few that we grew is that 1 year later, they were still only the size of a small coin. 2 years later, the size of a medium coin, and 3 years later, the size of a large coin. I got disappointed, thought this is no longer a technology we can utilize. And instead, I took it off the shelf of this aquarium and I put them all on the bottom of the aquarium and forgot about them. A few months later, I went to move that piece and it stuck. And so I yanked it and then I heard a crack and I broke a piece off it that had grown onto the bottom of the aquarium, the size of a large coin. And I looked at that coral and I said, ooh, that's going to hurt. And I better check this in a couple days because it may die, it may get infected, it may get stressed. And I looked back and I saw 3 little tiny polyps left behind in a dust of calcium carbonate with 3 little tentacles sticking up. And I thought, they're not going to make it. In fact, I said, they're toast. But you know what? That's not what happened. 2 weeks later, I went to look at the coral with the big hole in it, and it had already grown tissue back that had taken 3 years to grow, and it did it in a few months. I literally ran down the hall of the lab to look at those 3 little polyps. They had already grown up to about a dozen polyps, about the size of a large coin again. So this is crazy. What's going on? It became my eureka moment, or some call it my eureka mistake. So then went the science. So the science behind the mistake was to take a scalpel, take that same coral, and cut it again into tiny, tiny pieces. Pieces as small as 1 single polyp. And what happened is they grew back up to the size of a 3-year-old in just weeks or months. So something happens to these corals that causes them to grow fast when they are cut and hurt to very small pieces. The same thing happens to our skin. Our skin does not grow very fast until we fall down and scrape it. Then it heals over very fast. The coral is doing the same thing, and hence was born microfragmentation, cutting them into smaller and smaller pieces, and it worked with all the other 26 species of corals. So to give you a quick review, in the old time, we used to take a big saw, cut it into big pieces. We'd wait for each of those big pieces. We'd hold them far apart, and in 1 or 2 years, we'd cut them into 2 more pieces. Now we take a specialized saw. We cut them into tiny pieces about the size of a pencil eraser, or even down to 1 polyp. And from 1 piece, now we get hundreds, if not thousands, of tiny pieces, and they grow crazy in the next few months up to the same size. So now that it took us 6 years to produce 600 the old-fashioned way, we now produce thousands. And we've produced 25,000 corals this year and planted 10,000 of them back onto the reef. So now we have a new technology. And with the help of my assistant here, shown in the picture, we now in 1 day will cut 600 to 1,000 corals, and as he says, without a sweat. But what happened is we are now producing thousands in a day. We didn't have enough tanks. We usually put corals about 2 inches apart, and they would have a few years to grow because we don't like corals to touch each other. They don't like being overgrown by another coral. They will fight another coral. They'll even kill another coral. But what we found out is these things were growing so fast, we had to put them close together. And the picture on the right, in that area in the center, you'll notice these corals have grown up. They're touching each other, but they're not fighting. They're not fighting because they came from the same parent piece. It's like your skin transplanting to your other arm, and it recognizes that as itself. The coral in reskinning now knows that it's itself and will fuse back together. So we now can take the potential of reskinning, like your skin, onto an old coral head like on the left, get it to grow up, touch each other, and actually fuse. The upper picture are just our first 4 small pieces that we put next to each other. 11 months later, they fused into 1 coral that would have taken 11 to 15 years. Coral fusion is now a new technology. We can take a dead coral head that's out there, plant a few of these small fragments. In a few months, they grow over the fragment towards each other, and out in the field on the right-hand picture shows them fusing and touching together. That coral head was produced in 2 years and would have taken 25 to 75 years to grow. So now we can literally bring back corals back to life. A dead coral skeleton that may have been 500 years old. We can put 500 clone pieces on and in 2 years get them to touch, and we literally are bringing a half a century coral back to life in a couple of years. This is amazing. We can do something that I never thought possible before. Now, to go back to sex. The past few years, we've had better success than 10 years ago. A few years ago, we got 12. Then we got 25. Last year, 1,000. This year, 4,000 surviving out of those million. Now, I'm not saying this is important because we're going to plant these 1,000 instead of planting 1,000,000, but these 1,000 now are 1,000 genetic recombinations. There's no twins here. These are now all genetic diversity, and if we put these 1,000 out, we'll let Mother Nature decide in 5 years which of these are best to survive. We can also pre-test them now in tanks where we are adjusting the temperatures where we think it may be in 20, 50, and 100 years from now. But maybe we'll solve that too. And we change the pH to see which one of these are going to be winners and which one are going to be losers. Now think about it. I told you about 2 or 3 or 4 different new technologies. The real trick now is putting them all together. If we put these all together, now we can produce a lot of corals in a small period of time. We can get sexual reproduction to give us 1,000 new genotypes. We can test those genotypes to see which ones are resistant to high temperature, low pH, diseases, pollution. We can take those 2 that have each of those qualities, cut them up, refuse them back together into the size of a colony that would have been 25 years old. And oh yes, I forgot to tell you, if they go to the size of a 25-year-old, that's the time that they spawn. And even though these are only 1 or 2 years old, size matters. And so at the size of a 50 or 25-year-old, they know it is and they spawn. And so now we can close the life cycle of an entire selection of a 100-year-old coral in just the lifespan of a graduate student. And we can now do the amount of time and crossing that everybody on land did with dogs, cats, birds, bees, cattle, and everything. With the economy scale, we can plant 1,000,000 corals at less than $10 a coral. What? Let's do the math real quick. We had 400 corals a couple years ago. We cut them into 50, we get 20,000. 20,000 in 6 months, cut another 50 from each, we get 1,000,000 in 1 year. So we can take staghorn and elkhorn off the endangered species list in just a few years. We can restore the reefs in our lifetime. We can go from this, the old picture, back to the new picture, but with your help. So I'm going to ask you one last time to work with me here. Join me. Inhale. Exhale. You can now breathe easier, that we're going to make a change with technology. But you are going to have to join me in stopping the extra CO2 being put out. People ask me, what will it cost us to restore the reefs? I'll have to ask you, what will it cost us if we don't restore the reefs? Thank you.